In this video we're going to continue solving systems of linear equations. In our last video we did it graphing. This time we're going to do it just using our algebra skills. So we have a few different methods to get through. I'm going to try and let you know when using one method is better than the other. The first one we're going to talk about is called the substitution method. And just right off the bat, this method is best if one of our coefficients is 1. So this is what an equation might look like if you were to think that using the substitution method was the best method to use. So we're given two different equations. Again, that's a system. And our solution is going to be an x and a y value that will be a true solution for either of these equations. So whatever x and y is on this side, whatever makes it equal -4, should be the same x and y values that go in down here to make this equation equal to 2. So let's see what happens. Again, so this variable right here has a coefficient of 1. So chances are using the substitution might be the easiest, because if we just solve this equation for x, it's fairly easy to do. All we got to do is subtract 2y from both sides, and we get x equals -2y plus 2, right? All we did is subtract 2y from both sides. Alright, let's hold on to this equation right here. We're going to use it, and what we're going to do is substitute it into the other equation that we did not use to get this with. So we got to use this top equation. So instead of 3 times x, I'm now going to say 3 times what x is, right here, what we solved x to be. So -2y plus 2 instead of x. Rewrite everything else, and we're going to solve now for y. Distribute. So 3 times -2y is -6y. And then 3 times 2 is +6. Let's rewrite everything else real quick and continue solving for y. So now we got to combine our like terms here. -6 plus 4y gives us -2y. We're going to keep this +6 for a sec. Now we got to get rid of that +6, so we're going to subtract 6. And now we get -2y equals -10. And now just divide by -2, and we get y equals +5. So now that we have y equals 5, it's pretty important. It's going to help. It's part of our solution. We know what x equals in terms of y. It tells us right here. We already solved it. So all we got to do now is substitute one more time and solve for x. X equals -2 instead of y. Y is 5, so we're going to use 5, and then add 2, and that's what x equals. So -2 times 5 is -10. If we add 2, then we get x equals -8. So we have our x and our y value, and we can place it in our coordinate pair form, so -8 and +5. That's our final answer. That is the intersection of these two linear equations, or these two lines. Now, how can we check it? Well, if we actually substitute our final values into each equation, like I said earlier, it should be the same x and y value, and we should get our solutions for each equation. Let's see. 3 times -8 plus 4 times 5. Does that equal negative 4? Well, that's 3 times negative 8 is negative 24. 4 times 5 is 20. And if we add them together, then yeah, we do get negative 4. So it's in fact a solution to that equation. Is it a solution to this equation? X negative 8 plus 2 times 5. Does that equal 2? Negative 8 plus 2 times 5, that's 10. Does that equal 2? Yeah. So again, it's a solution to both equations, the exact same values. Alright, so that was the substitution method. And again, we chose it because the coefficient of one of our variables was 1. It made it easy to solve for one variable and substitute. This method is called the combination method, or the combo method. We're going to combine two equations by simply adding them, and we should be able to solve for x or y. So let's see how to do that. If we're given an example like this. Now, in these two equations, neither of the coefficients of either variable, so the number in front of x or y, neither one of them is 1. They're all greater than 1. So solving for a variable is going to be slightly trickier, especially if they're not, if these numbers do not easily go into this bigger number right here. So in that case, it's always better to use what's called the combo method. And the way to combine these two equations is to try and get rid of or add the opposite of one of these variables. So I can either try and get this equation to be negative 4x, so that the x's combine and go away, or I could get our y's to be the same number, which seems like that would be a lot harder, right? So in this case, you always want to choose whichever variable seems like the easiest to delete or get rid of or cancel. In this case, we would definitely want to go with the x's. So if I just simply multiply everything in this top equation by negative 2, so change everything by a factor of negative 2, then I will get a negative 4x and my x's will go away. Let's see what happens here. So I'm distributing this negative 2 all the way through. So negative 4x, negative 2 times negative 4 is a positive 8y, and then negative 2 times 13 is negative 26. So let's just move this equation right below it again so it's easier to combine. And now I just simply combine top and bottom equations. So the negative 4x and the positive 4x are going to go away when I combine these equations. So no more x's. But now I have 8 y's, and I'm going to subtract 5 y's, so I get 3 y's. That's going to equal whatever these two numbers combine to make. So negative 26 plus a positive 8, that's going to give us a negative 18. Now to get y by itself and solve for y, we divide by 3. And then we get y equals negative 6. So we want to keep that. And what we're going to do with it is substitute it back into either one of these first two equations. We could also use this newer one that we made, but usually those numbers tend to get bigger and they're not as easy to work with. I always substitute this value into whichever equation makes it the easiest. So I think multiplying multiplying negative 4 times negative 6, I guess, is slightly easier than negative 5. So I'm going to substitute it into that first equation. But again, it doesn't matter which one you do. So 2x minus 4 times, now negative 6 instead of y. And now we're going to solve for x, because that's the only variable in this problem. So 2x negative 4 times negative 6 is positive 24. And to get x by itself, still we need to get rid of this positive 24, so let's subtract 24. So 2x equals, what is that, negative 11. And then to get x by itself, divide by 2. And x equals negative 11 halves. I'm second guessing myself, but we're actually right. Yeah, everything works out. Negative 24 plus 13 is negative 11, and we divide by 2. It seems strange, but fractions are possible. A better x value might be to turn this into a mixed number or even a decimal to make more sense when you graph it. So let's do that. We can turn it into a mixed number. How many times does 2 go into negative 11? 5 times without going over, right? And there's still a 1 left over, and 2 is our denominator, and since it's negative, we keep it negative. So negative 5.5 could be our x value. So our coordinate pair is negative 5 and 1/2, and our y value is negative 6. So this is our final answer. This is the intersection of those two lines. If we were to graph it, we would find that this coordinate is actually where the two lines meet. So that was the combo method. And in the next video, I'm going to talk about a few more differences in solving systems of linear equations and getting their solutions.